Please welcome to the stage Corporate Vice President and General Manager, Cloud and Enterprise Solutions, Janet George.
Hi, everyone. Thank you for the welcome. All right. Today's digital transformations are creating an unprecedented opportunity. Investments are estimated to be about $6 trillion between 2022 and 2024. More data is created in the next 3 years than in the entire past decades. 70% of organizations have stated that they have accelerated all of their cloud migrations. And IDC is reporting to us 64 zettabytes of data, new data, created in 2022. And it's projected to rise to about 180 zettabytes of data replicated by 2025. And with this trend comes shifting architectures, applications, associated data, all in continuous evolution. And the rising adoption of cloud comes rising demand. And as you see, we need infrastructure, tools, technologies to optimize and to enable this at scale. The right capacity that we need, which is optimal to manage the cost, and then the ability to have burst out capacity. We also need cloud tools and optimizations that are effective for the fleet management and then the fleet operations. We need optimized applications that benefit from specific hardware offloads and acceleration capabilities. And we also need to manage the total cost of ownership at cloud scale with deep environmental and sustainability considerations. Now, all of you know, we live in a data-driven world, right? Data is becoming increasingly a big strategic asset for us. And most enterprises have to figure out how to transform this data in order to unlock the business value. And they have to be AI-ready, AI-powered, if you will, and unlock this value of machine learning and AI. And our approach to accelerated computing is rooted in systems. We develop silicon, and we support software ecosystems. This is enabled through an unmatched portfolio with sustainable solutions at scale. We have an expansive partner ecosystem. We work with them to complement our portfolio and to, most importantly, get freedom from proprietary programming methods across all architectures. At the very foundation of this is Xeon. We have billions of Xeon cores today powering cloud infrastructure. We have a steady heartbeat of innovation with Xeon and our partners to really understand new usage patterns we have never seen before, and benefit with efficiency improvements. Since its inception, customers have deployed greater than 100 million instances of Xeon scalable processors. We are focusing on creating performance advantages across a breadth of industry verticals. And we are seeing up to 30% increase in these performance improvements and utilizations, which actually saves our customers thousands of dollars in cost, or sometimes even millions. We are engaged in very deep technical partnerships with our customers. We're co-innovating with our top technical talent and with our customers. Our optimizations are the fastest growing in workload areas like AI, data, security, analytics, performance, benchmarking. And we do all of this with really deep partnerships with our ecosystems and our long-standing partnership with Oracle. It actually helps us to bring this co-innovation to the market faster for our customers. And our partnerships and collaborations are very important to each other because we leverage each other's deep insights and deep knowledge. Beyond Oracle's rich history of delivering enterprise applications, Oracle built their business for the cloud, offering a very broad availability globally. And they've also built modern SaaS versions of pretty much all of their business applications. Oracle's cloud infrastructure, OCI, has more than 80 cloud services. And then Intel offers the widest range of instances along with deployment options. Our scalable processor helps you ensure that you can develop once and you can deploy anywhere on a public cloud, private cloud, a hybrid cloud, or even bare metal. So you can use any one of these instances, and it offers the great cloud choice and application portability, which is very important as you move from different clouds. It is a world of multiple clouds. Intel offers the greatest breadth in optimized open source software, and we are a major contributor to our open source ecosystem. We're meeting the demands of sustainability. That's a common request from all of our customers. They want sustainable instances in these data centers based on Xeon, and we're building it with 80% renewable energy, something we're very proud about. All right, now our 4th generation Intel Xeon scalable processor, which we are formally calling it as Sapphire Rapids, is built on some advances to redefine our processor performance. This is a little bit long time coming. And the features are the most built-in accelerators of any CPU in the market that you will find in performance, in analytics, networking, storage, and HPC. And they are establishing a new standard for us in data center architecture, delivering potent infrastructure from the cloud to the edge to the intelligent network. They're also significantly improving a large array of workloads, enabling greater performance at data center scale across a wide variety of customer applications. We're delivering substantial compute across different traditional data centers. We have unique built-in workload optimizations for artificial intelligence and cloud microservices. One of the fastest growing workloads that we are seeing right now is the microservices workload. And then Intel's 4th generation Xeon also includes general purpose compute. We're calling it the performance core, the P-core, and with a wide range of broad data center relevant workload specific accelerators. So let's talk a little bit about the 4th generation Sapphire Rapids advanced accelerator capabilities. This generation is the most AI capable yet. And as you know, AI performance is very significant and it's required in all tiers of the computation. With Intel Advanced Matrix extensions, we're able to look at matrix multiplication much faster than we normally do. And this is a dedicated hardware block built alongside each core to increase the performance of AI, deep learning, and all of your training workloads. We also have a new data streaming accelerator. I'm very excited about this one, Intel DSA, which offloads the data movement from the CPU core to improve the performance and power efficiencies. Now, as you know, data transportation is a big problem, especially when you have data pipelines and you're trying to bring all this data and unite the data to form the training sets for your AI applications. Featuring up to 60 cores with the latest DDR, PCIe Gen 5, platform technologies built on industry-defining accelerations we're bringing to these optimized workloads around AI, cloud analytics, storage, networking, security, and more. All right, so what you're looking at is some data. I'm a data person, love data. So let's look at the data. So what you're seeing on the screen is a couple of HPC popular benchmarks that we use for server performance evaluation. You're looking at 2 here. One is a star CCM benchmark, and the other one that you're looking at is a Lehman's and ANSYS Fluent benchmark. So the graph on the left, which is the star CCM benchmark, that measures the average elapsed time in seconds. And you can see in that graph, lower is actually better. On the right, you're seeing ANSYS Fluent measure, and the computational performance there, higher is better. So the light blue that you're seeing are previous Xeon generations, and the dark blue that you're seeing on the graph is the current Xeon generation, which is actually Ice Lake. And this is an HPC workload that we're running on OCI with 3rd generation Intel Xeon scalable processor. And you can see that with the combination of an Intel AVX 512 instruction set and an optimized Intel math kernel library, you can experience about 30% increase in performance over Gen 2 Intel with the same 36 cores frequency CPU SKUs. Now, you might be wondering, okay, does this actually scale? It does. This performance can be scaled from any single set of nodes to as many multiple nodes as you can. All right, so some wonderful results. And now I'd like to share with you this co-innovation with Oracle. And I'd love to invite Matt Leonard, Vice President of Compute, Product Management for OCI, to the stage. Welcome, Matt.
Thanks, Janet, for having us up here. All right, I want to talk a little bit about Oracle's relationship with Intel. They were our first strategic partner, and the platform, Gen 2 Cloud, was built on top of Intel. We use it from everything from our customer-facing shapes in our HPC and standard compute, all the way out to some of our internal managed storage services that we use that power the cloud under the hood. Today, we have 3 generations of Intel that are available across a variety of shapes. With our 3rd generation Ice Lake shapes, based on the Ice Lake shapes, we see 60% better performance than we saw on our previous generation Skylake that's still available on the cloud. So amazing performance enhancements. That partnership with Intel has allowed us to create innovations that help you build total cost of operation efficiencies. And so some of the things that you'll hear about at other sessions at Oracle CloudWorld, flexible compute, right? Like partnering with Intel, we were able to launch flexible compute on our X9 Ice Lake-based shapes that allow you to optimize the shape of your workload relative to what you need to deliver value for your customers. So we continue to innovate there with other cost-efficient solutions like burstable compute, preemptible, and you can learn a little bit more about those in Sanjay Pillai's session on Thursday, Dial in Maximum Value with Oracle Cloud, if you want to learn more. A continued relationship with Intel, we're excited to announce our support for the 4th generation based on Sapphire Rapids. We're expecting to see significant performance enhancements that are going to help you as customers, like with your most demanding workloads. If you want to hear a little bit more about some of the other innovations that we have coming, I'll do a shout out to Greg Pavlik as well, our SVP of Core Infrastructure. He's going to be talking about a number of announcements that are coming from the Core Infrastructure group, including compute, and the session Radically Simplified Infrastructure. That's at 3:45 tomorrow. So, Janet.
What really excites us most is that customers are doing pretty remarkable things with OCI and Intel technology. And I want to take a moment to introduce Kobe, our CFD engineer from Richard Childless Racing.
Welcome, Kobe. So, customers are always more interesting than listening to us talk about our products. So Kobe and his race team leverage OCI and our optimized 3 shapes in order to get ahead and stay ahead of the competition in the US NASCAR events. Kobe, I'll give you that.
Thank you.
Thank you. So for those of you who follow the NASCAR Cup Series and Xfinity Racing, Richard Childress Racing is a name that you'll recognize. They've got a long tradition of success with the legendary number 3 and number 8. This includes a stunning 16 championships, 240 race victories, and a commitment to winning and innovation that go hand in hand. So, Colby, great to have you with us here today. Can you tell us a little bit about how Richard Childress is using Intel and OCI in order to deliver innovations in racing?
Yes, thank you, Matt. It's great to be here. As you mentioned, all of us at RCR Racing are constantly looking for ways to win, not just on track against our competitors, but against our biggest challenges, time and money. My role as the CFD engineer in the aerodynamics department focuses on design optimization and ways to deliver the fastest cars every weekend. And to do that, we come up with aerodynamic design ideas for all kinds of things, ranging from new car positions to developing components that would otherwise be unaerodynamic to give us an aerodynamic advantage. A great example of this is taking a seemingly mundane suspension component and developing the shape to also provide an aerodynamic advantage beyond its suspension duties. To do this, we model those parts in CAD, test them in CFD simulations, and then pass the most promising ideas into the wind tunnel to validate before they land on our race cars. We do this multiple times a week, and it's constantly a race to get things turned around in the fastest time possible. Our previous HPC vendor provided around 800 cores dedicated to testing our digital ideas before we could land them on our RCR Chevrolet Camaros. But we wanted to do more. So we looked at OCI HPC solutions built on the Intel optimized 3 shapes. And with fantastic support from Oracle, we were able to stand up a proof of concept environment almost overnight and to test drive those clusters. And what we saw with those clusters is we were able to leverage almost double the performance, meaning we could turn around 2 times as many cases in the same time frame. This is incredibly important for us because it meant we could test more ideas, get the results faster, and our engineers could spend less time waiting for simulation results. It also means we can iterate more quickly through design ideas to get to a positive aerodynamic device. The end result, we can move faster each week iteratively to deliver the best aero enhancements to our cars that give both our drivers and sponsors the best chance to finish in the winner's circle.
Kobe, this is like great story about performance where it matters. And I believe there's some financial advantages.
Yes, that's correct, Janet. And where we see that the most is in the wind tunnel. Our development process of modeling and then testing simulations in the OCI compute with Intel helps us test more ideas more quickly to determine which parts ultimately get sent to the wind tunnel for validation. Wind tunnel testing is incredibly expensive, on the order of $20,000 an hour. And furthermore, we are regulated by the sanctioning body NASCAR on how many wind tunnel hours per year we are allotted. So by being able to simulate more ideas, we can get through more design iterations in CFD. That guarantees only our best ideas are brought to the wind tunnel. And that really allows us to maximize our time in the tunnel, and we operate more efficiently. Intel in the OCI cloud really helps us squeeze out every dollar and every minute we get in the wind tunnel to deliver just the very best aerodynamic enhancements.
Wow, that's impact for sure. And with using Intel in the OCI cloud, we have the ability to transform at scale. Tell me, how much more can you get done?
Yes, the scalability is an incredible component for us. It's really crucial to have the ability to dial up as many cores as a project requires. That really prevents us from having to sideline a large compute-heavy project. The sky's the limit for what we can do now. There's really no limit to where we are for projects. What's different from our old approach is we can think more creatively and consider more options. We really love that we can scale to meet the most challenging simulations each week, and we can see new ways for how we can leverage OCI and Intel creatively moving forward.
Fantastic. Kobe, any other things you'd like to share with our audience?
Yeah, if you're interested in learning more about how we use OCI and Intel for our race department, please consider coming to Winning the Race with Oracle Cloud Infrastructure Thursday at 10:15.
Thank you. Well, thank you, Matt, and thank you, Kobe.
Thank you, Janet.
Thank you, Janet. Appreciate your time.
Thank you. All right, wow, that was really awesome. Intel is renowned for our hardware, but many people don't know that we actually have deep software roots. We are actually a microprocessor company, but we have more than 19,000 software developers. And we have trillions of lines of code optimized for Intel on more than 100 different operating systems. For over 2 decades, Intel has driven innovation from data center to the cloud and to the edge through open source technologies and our communities. Intel is the #1 contributor to the Linux kernel, with many processor-level features requiring OS enablement. And our Intel Linux engineers fine-tune performance with flame graphs, and they activate new performance features in the kernel to test them with rigor and then upstream them to the kernel maintainers. We just led CPU optimizations with Google on TensorFlow, and we are one of the original key tech leaders for Kubernetes. Now, we want to make it easy for everybody to get the best of Intel for your specific needs, applications, and workloads. With tools optimizing for your existing cloud solutions to take advantage of your available capabilities, maximizing your performance, and reducing completely your cost. We allow for smart instances and then cloud management aligning with your software performance needs. We provide better benchmarking, moving towards active system-level benchmarks, which is different, and then give you a more accurate picture of your real-world performance for all of your modern applications. Now, Intel offers a wide range of best-in-class optimizations for developers, harnessing all of your hardware capabilities that we already built into your infrastructure. Intel also has optimized applications to make it easier for your consumption. Now, you may have heard about Granulate. This was a recent acquisition for Intel. And time and resources are really critical, and they're limited. So every developer wants to improve their performance, and they want to lower their cost in the cloud. Granulate offers you real-time, autonomous application optimizations with almost zero code changes. With Granulate, companies can improve performance while they lower their infrastructure cost and also their cloud cost. And it's continuously adapting to your application's work patterns as it's optimizing for performance. What I didn't know was it can do application-level resourcing and optimization. So Granulate's customers are reporting really fabulous results with time to value in less than a week. Here's a demo.
Enterprises no longer have to choose between improved quality of service and saving on infrastructure compute costs. Granulate provides you both. By optimizing resource management in real time at the operating system level. OSs were designed as general-purpose solutions with the user behind the keyboard in mind, while production infrastructures are made for specific tasks with repetitive patterns. So OS resource allocation is never fully aligned with your specific service data flow. For example, every user request might trigger multiple requests to other services. The front-end server processes the received responses while it waits for the rest, even though other users' requests require the same resources and are ready to be served. The only way to resolve this efficiently is by knowing the specific application data flow and processing stages. Here's how Granulate does it. Our agent is installed on an instance and learns its data flow, resource usage patterns, and processing stages. Once activated, it optimizes application-driven scheduling and prioritization decisions of the main contended resources, constantly adapting to changing traffic and new versions deployed. You get autonomous, continuous, real-time, optimal resource allocation with improved performance and lower costs. All this with zero code changes and one command line installation. Start with a single VM and see results after several days. Even on top of other installed solutions, Granulate will deliver between 30 to 60% cost performance value. And it integrates with any infrastructure. You too can enjoy the value we create for our customers.
All right. So the underlying foundational infrastructure matters for availability and for scale. More and more applications are requiring critical elements to address not only performance, but security, manageability, and resiliency. CPU memory is not enough. You need differentiated features for performance, scale, and cost. Workload acceleration enabled on Intel, from high-performance computing to deep learning and to databases, all depend on the right instruction set. Intel offers a broad range of capabilities, features, tooling, and software compatibility, with the widest range of instances and deployment of these instances across many regions and geographies. Now, I want to talk a little bit about the data center. Intel is defining an intelligent data center architecture from edge to the cloud beyond the CPU. And this new architecture requires large-scale distributed compute to work together seamlessly to appear as a single compute instance. We're also investing in microservices performance engineering and benchmarks, as we talked about, Death Star benchmark. Our optimized container solutions are released through our Intel Container Portal. And this opens up collaboration opportunities to improve the performance at a total cost of ownership for the CSPs and for the enterprises at scale to monetize all of the solutions portfolio, landing the optimized workloads in the intelligent data center, differentiating end-to-end ecosystem advantage. Intel's GPU is a flexible, robust, open solution for the intelligent visual cloud. Our GPU supports standard-based software stack optimized for density and quality, and with critical server capabilities for high availability, reliability, and scalability in media processing, again, delivering AI visual inference, cloud gaming, and then virtualization at scale. Now, as AI becomes existential for your business outcomes and enterprises needing all this tooling and approaches that guarantee the security of data, I can't tell you how many times I've heard customers talk about security as pivotal to their data transformation and to their data movement. Trust is foundational as data gets harnessed at the edge and at the cloud for the AI applications. Today, an average data breach is costing about $4.2 million. And it is understandable that many of the IT leaders, 60% of the ones that are interviewed, are increasing their security budgets. To ensure that we're not only compliant, but also in privacy and security, we have to defend against these threats. And businesses need to take a zero trust approach, protecting the data while it's in use, hardening security at the silicon level, and then minimizing the impacts for performance with ease of use, protecting the data, and then building on the trust. Now, Intel has confidential computing technology portfolio, and we help our cloud providers and our developers with this. At the core of Intel's confidential computing is Intel SGX and our upcoming Intel TDX technology. Both of these enhance security, privacy, and data sovereignty by limiting which software and administrators can access the cloud tenancy data. With TDX, only the software inside the VM and then the tenancy administrator inside the VM can access the hosted data. So this puts the cloud stack, the cloud administrators, and other tenants outside that VM, outside the trust boundary. SGX takes isolation even further by creating a protective enclave. And this enclave only permits confidential data accessed by single application or specific isolated functions. Both SGX and TDX put the cloud tenants in control of their data, even in the public cloud. So this level of data confidentiality, privacy, sovereignty can be major differentiators for the cloud enterprise and then for the cloud operators. And it is also a major growth driver for all of those sensitive workloads, those laggard workloads that are really terrified of going or migrating their cloud workloads to a public cloud because they're worried about security and data breaches. So another core workload that requires infrastructure transformation is networking, as all of you know. This is where the IPU comes into play. So this is an infrastructure processing unit, an advanced networking unit with hardened accelerators and Ethernet connectivity that accelerates and manages your infrastructure functions, which are tightly coupled, dedicated, programmable core. Now, an IPU has several advantages. One is the strong separation. We love abstraction because abstraction gives you flexibility. And the strong separation of infrastructure functions, for example, networking and storage. These tenancy workloads allow the tenants to take full control of the CPU with the infrastructure functions, securing and running them on the IPU. Now, the cloud operator can offload all of the infrastructure tasks, think delegation, right? Like networking, storage, microservices to the IPU. So the CPU does not have to take all of that load, and the CPU utilization and revenue is maximized. Now, IPU can manage storage traffic. It can also reduce your latency while it's efficiently storing capacity with a diskless server architecture. And with our IPUs, customers can better utilize their resources with secure, programmable, stable solution that can balance both their storage and their compute processing.
I'm here today to introduce you to a product I'm really excited about. That product, codenamed Mount Evans, is our first 200 gig ASIC IPU, or infrastructure processing unit. We have architected and developed Mount Evans hand in hand with a top cloud provider. This has provided tremendous insights into deployment requirements for networks at scale. Intel has been working closely with other cloud providers through our FPGA-based solutions, and our learnings with those products has influenced many of the Mount Evans architecture and design trade-offs. Mount Evans has been designed for performance at scale under real-world workloads. Finally, in order to be hyperscale ready, we designed in security and isolation from the ground up throughout the chip. On the technology front, Mount Evans is loaded with innovation. To start with, the focal point of the product is what we believe to be a best-in-class packet processing engine that supports a large number of existing use cases like vSwitch offload, firewalls, and virtual routing, as well as providing significant headroom for future use cases. Another technology, created by extending Intel's proven high-performance Optane NVMe controller, enables Mount Evans to emulate NVMe devices. A third technology innovation I'm excited about is a next-generation reliable transport protocol. We have co-innovated on this technology with our CSP partner to solve the long-tail latency problem on lossy networks.
All right, so Intel has a broad portfolio of IPUs. Intel 200G IPU, the 2000 that you just saw, Mount Evans, is now in production. Our IPU roadmap outlines IPUs well into 2026 with 400 and 800G offerings. Pulling it all together is the software, and Intel, as we talked about, is a software enabler. We are a founding member of the Linux Foundation with open programmable infrastructure, which is creating standards for open infrastructure software, and then our open infrastructure program development kit, which is now part of the OPI project. So Oracle and Intel, we have a long-standing partnership and a relationship. We are very excited to continue this partnership well into the future. We are both here to help you and to provide you with solutions to solve your business challenges. Our 4th generation Intel Xeon Scalable processor, Sapphire Rapids, is here for your most demanding workloads. And I would really encourage all of you to reach out to your Oracle and also to your Intel sales folks for more information. And if you'd like to hear more from us, from Intel, you can visit our session tomorrow at about 11:30. And is it possible to scale memory with less DRAM? Very interesting. You can also speak to us in the Intel booth. We are here for you. In cloud and database communities are here for you as well. So thank you, and we can't wait to see what you will all do next.